Okay, so here's a question. It's one of the harder questions conceptually. Now, mathematically, once you've found the right model and explained the model, the maths is quite easy. It's just piecing the model together. So let's go through it line by line. So Stuart's terrible at basketball. The probability of him shooting a basket from the free throw line is 15%. I mean, so right away we might just want to write P equals 0.15. If we assume this probability remains constant, well, that's kind of important, right? If it remains constant, then this is one of the conditions under which the binomial distribution is valid. So that's a pretty good thing. Calculate the probability Mr. Sturrock scores at least 2 baskets out of 10 attempts. Okay, so let's go and write down a model. We have let x equal the number of baskets scored. And then we write down our model. X will follow a binomial distribution. There are 10 attempts or 10 trials. The success for any one trial is 0.15 and it remains constant. It just means that every shot is kind of independent of the previous shot. So it's kind of a realistic model, but it just assumes that over the 10 shots, the probability of success doesn't change, it doesn't get any better with practice of 10 shots or doesn't get any worse with fatigue. And so what we're trying to find is the P probability that are at least 2 baskets, so greater than or equal to 2. And so we need to find out this, and we can get this straight away on our TI-Nspire. So greater than or equal to 2 sounds like a cumulative score we need. So let's just go to it now. And on here, doc, insert a calculator, menu, probability, distribution, and down here is binomial CDF. The number of trials is 10. Success is 0.15. Lower bound is 2. Upper bound is 10. And off we go. And so this probability is equal to 0.456 to 3 dp. Alright, this second part is just a little bit more challenging. Has a little typo here as well. Mr. Stewart wants to go home and tell his family he scored at least 2 baskets at school today. Now let's just take a minute to think about what's going on at the moment. With 10 shots at the basket, the chances of getting 2 or more is 0.456, about 45-46%. And so you can see that Mr. Stewart just needs to take more and more shots at the basket until he's kind of almost certain of getting 2 or more baskets, okay? So we want that probability to increase to up to 90%. So what we're looking for is maybe we want now to change the variable to y, and there's a mystery number of shots. The probability stays the same, but we want y now greater than or equal to 2, and we want this probability to be greater than 90%. Now that's quite a bit of a statement here, but actually once we translate it into the calculator notation, it becomes quite easy. So what we've got back on the calculator is that we go up, up, bring this down, and we need to change the number of shots to something bigger. Should we try 20 shots? And then this changes from 2 to 20, of course. So there you go. Already, if Mr. Stewart takes 20 shots at the basket with a 0.15 chance of getting 1 basket in, then you've got this increased probability, 82%. So we want to keep changing those numbers till we get somewhere just above 90%. Oh, that's good. And this is just guess and check, I suppose, would be the way of describing it. And we've got it, look, as we move from 24 attempts to 25 attempts, there we hit the magic 90%. So we have our answer now. We need the number of shots to be, greater than or equal to 25. So if we take 25 or more shots, we've got a 90% or more chance of getting at least 2 baskets. Okay.